So let me try to figure out what you're saying here. So
No, no, well, this would be a sine b equals a squared plus b squared minus c squared, something like that. And then divided by 2ac, something like that.
I have no idea.
Okay, never mind.
That must be specific to a problem.
Yeah.
Yeah, it's not really a direct part of an identity. They might have or a law.
Well, they use that. I think it was in here. I'll bring it up.
What is times sine 3 plus cosine 3?
Yeah. Okay. How about this? Question number on 6.6. This is on question number 7.
All right, cool. All right, so 7 has this triangle here.
Pull it up.
42.
Which section? Six or seven?
This is section 6.6. Yeah. So it wants me to find that angle specifically, right? Now, what situation am I in? Do I have an Aristotle here, or what do I have? That's what I thought she said. Yeah. This is side, 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 right? So it's very obvious I can't use law of sines because I don't have any angles to make a complete ratio. So law of sines out. If I want to get that angle specifically, then what two signs do I have to use in the formula?
C, A,
Yeah.
and B.
Oh,
There's
do they label those?
No.
Screw the A's and B's and C's. Just tell me which ones.
68.
Yeah, 68
42.
and 42. The one that has that included between them. That's the whole idea. That C would be between A and B. So that's the included angle in that formula. Cool. So the general formula wouldn't have any C's, A's, and B's. It would be the angle between the two sides, those two sides there, and the side opposite that angle is there. So you can see why we wrote it out instead of just had a paragraph about it. So if I call this A and I call this B, just kind of fall into my formula.
Sure.
C is my theta, big old C. And little c, of course, is that dude there. I have no idea if that matches the book or not here. So now, what do I know? I know c squared. So I think they might have tried to solve the equation before they plugged things in. I don't know.
No, they set up the equation as cosine b equals a squared plus c squared
Maybe I
minus b
should.
squared
Let me go ahead and make this the same as the
divided
book.
by 2ac.
All right, so in the book, this is B. And this is C. So this must be A. Okay. So which means I'm going to use this kind of option for the formula there. So are you with me?
Yeah.
So then B is between A and C. B, the angle between A and C, there you go. Cool. So they start filling it in. B here, 37.83 squared equals A squared plus C squared minus 2AC cosine of the angle. So part of me wants to say, screw what the hell that does. We know how to solve equations, right? This is like x. I'm going to solve for this first, and then I do the inverse cosine. So just square all this stuff, subtract that crap over, divide by this mess, so you get cosine by itself, and then take the inverse cosine. So I really don't know what weirdness they decided to do there, but very often they'll do things in not the easiest way. That's all you have to do to solve this. So, is that cool? I mean, law of cosines is really kind of nice once you realize there aren't really three equations here. They're all the same one. It's totally arbitrary what do you call A, B, and C here. Because there is no hypotenuse anymore. Who cares? Yes, sir.
Where can we find all the trig identities?
Say again?
Where can we find the trig identities?
Where can you find them? So if you look on the very back of your book. Cool. So if you're going up further in mathematics, when you get the book, the first thing you do is you go to the back, you go to the front, you look at the answers, so you know what the hell you got. Because some books are going to have loads of crap in the front and the back. Some are going to have nothing. Some are going to have all the odds. Some are going to have random answers. 1, 2, 28, 29, 47. It's good to know on the first day what the hell you're working with.
So with the law of cosines, you just need two sides in order to find the.
Yeah, the law of cosines would work with if you knew this angle and these two sides, it would work. The law of sines could do a damn thing with that. The law of cosines would eat that up. That's not the situation I have there, I know. So it works with side, angle, side, and it works with side, side, side. That's the one we have there.
So you can use that when you don't have the angle.
When you can't make that ratio, that's law of sines requires. Law of sines requires an angle and its related sine. If you don't have that, it must be a law of cosines idea. If you do that, have that, it might be either one. Okay. Anything else we want to do? It's a review day. You can take a break when you want. Yeah.
Can I get one of the answers?
Yeah, let me go ahead and give you guys the answer key. By the way, guys, how many of you guys have gotten on there and played with Wolfram Alpha? Anybody?
It's not that easy.
Yeah, I do.
You
That's
know,
so
you
easy.
have to like, in order to like get the
It
stuff.
takes a little getting used to as to what language it understands and how to put things in.
Yeah, like to get the.
But they have a ton of examples. And they have it broken down pretty far, it's broken down into almost exactly what you would want. But if you put in there a trig function, like a trig graph, y equals 2 sine of 3 pi x or whatever, it'll graph it for you, and a little bit further down the page, it actually tells you what the hell the period is. I hadn't even done one in a while, and I realized they added that in. It tells you a lot more than it did before.
Oh, hey, hey, I have a problem.
Oh, yeah. What's up?
Number 23. Oh wait, you gave it to me.
Oh, yeah. Check that first. Hopefully I did it.
No.
Yeah. 26 and 30, right?
Okay.
Oh, yeah. I restate. So 5-1 up to 7-2. 7-2 homework. You don't have to turn in yet. What did you turn this in? Oh, yeah. Yeah. Because that's cosine alpha, cosine beta.
I failed somewhere
Right.
apparently.
Cosine alpha plus beta. Cosine alpha, cosine beta. Plus alpha. Don't I have it all there? Yeah, I do have it all. So cosine alpha plus beta is cosine alpha, cosine beta. Plus sine alpha, sine beta. This plus this.
Yeah, I got that. I got all that straight.
Oh, you have me.
Do we have?
Is that I got like I don't have
Yeah,
to
memorize
or
those.
whatever that is.
These actually come right off in this, but we'll talk more about that in the next time. These are the ones I'm definitely.
This paper or that paper is the one with square, like 1 unit square. Yeah. Remember?
Oh, the value.
Yes.
Yeah.
Just using the paper to sign and
Yeah, and it needs to be talked about more than just that. Like science squared, one, and those, and the value, cosine, I already told you, cosine. Oh yeah, so that, right, I should have made that here. So in that case, you're right, I should have put the arrows in there.
Go over question like number one.
Yeah,
Just
yeah,
like the basics, finding the sixth trig. Simple stuff like
Oh yeah.
So did I just have those spots messed up?
Mr. Waller, what's the whole the area
Yeah, I
of the
just
triangle
had
using
the
the law of
values
cosines
on
thing
there.
again?
Okay, I just want to do this. So kind of the new thing I did there was I didn't give you the picture, I kind of described it. So I told you C's 90.
Could you do different numbers?
How do you mean? Oh,
Different values?
sure.
Just trying to
So say C is 90, B is 2, and little c is 13. So then this is C, and then I don't care about A and B really. So this is 13, little c, and little b is 2. So little a, I don't know. Yeah. Yeah. So this is beautiful. This is the right triangle. It's funny how I clear the place out when I get the key out. They're all ready for it though. So A of course is going to be
big letters is always angles, right?
big letters, angles, little letters, sides.
165.
Yeah, 169 minus 4, so 165. That's 5 times 31, so that won't go anywhere. It's 5 times 33. Still won't go anywhere.
No, it's not 5 times 31.
5 times 33. One of those.
But it won't go anywhere.
It doesn't matter. It won't go anywhere. So now I want to know all the 6 trig values for the angle A, which of course I put it there.
Wait, how'd you figure out 8? What again?
Let's say find trig values for B. I made a new problem anyway.
Yeah, 2 and 13.
Yes, Pythagorean theorem.
Okay.
Yeah, so square root of 13 squared minus 2 squared. What I'm seeing a lot in the homework is people are just adding these without thinking. Right? The hypotenuse is the sum of these two, so of course I've got to subtract if I don't know one of these sides here. So be careful about doing something like that. And now it's just, do you know your ratios for all your trig values, right?
2 over 3.
So sine,
Y over
2 over 13.
say it.
Y over H.
Good. So that would be 2 over 13. And I know it's y because I've got the angle B in the base. So as long as the angle I'm talking about is in the base, I can do y is sine, x is cosine. If I was talking about angle A, this isn't y anymore, it's x. I'd have to put that in the base.
Or you could soak it so.
I know you can suck a toe. That sounds like telling me off, but sorry. You just go suck. So sine of B would be 2 over 13. Cosine would be, yeah, x over h, so root 165 over 13.
Tangent is Y over X.
Good. So 2, so just rationalizing that thing. And then the secant, cosecant, so cosecant, secant, and cotangent, just for reciprocals, yeah. 13 over 2. And the nice thing is if I give you a triangle is there's not going to be anything negative.
And it's in the second
It's a
quadrant.
triangle, it's the lengths of a side of a triangle. There are no negative sides. It's only when I give you something not directly related to lengths of the sides of a triangle. So like I tell you tangent theta is 2/7, and you're in the second quadrant or third quadrant. Secant B would be, in cotangent I can start with, this is going to be roots 165 over 2.
And you said when it's related to the angle that's on the base, we know that that's y and that's x. But if it goes the other way, then 2 would be x.
Then I just have to look at it like that. That's x and that's y. Or you SOHCAHTOA.
I mean,
Like I said, that's
you go over
the.
SOHCAHTOA real quick. I know, like you don't like it, but
No,
It helps you just with these triangles. Like if you remember that x and y, that gets you so much further. But without triangles, it helps.
So SOH, so sine is opposite over hypotenuse. So if you're talking about A, sine would be opposite over hypotenuse. And I would just go like that, that's Y, that's that. That'd be H. Right? Cosine A, right? So cat, so adjacent over hypotenuse. And tangent OA, right? So opposite over adjacent.
I don't like that. I'm going with the base.
So SOHCAHTOA has an advantage when my triangle isn't set up right. That's the only advantage it has. If you know y and x, that gets you so much further. And how difficult is it really to just redraw this turned around?
Yeah.
Not. So, yeah. You don't have to just say that if you don't mean it. Sorry.
No, yeah, I do. Because I looked at that and I was like, yeah, screw that. I want you to remember the base.
Y'all don't trust me too much, but trust me. I mean, I want to talk to you guys again when you're 3/4 of the way through calc. Anybody's taking calc, and then you'll be like, "Thank God you showed me that." If you were just doing SOHCAHTOA, it would not help you at all. Yep.
I want to know with 6.6, 36. Yes, please.
Oh yeah. Yeah, that's cool. Oh, is that you were asking about?
Doing that right now. Yeah, I just got it out.
That kid. All right. It takes me back to my childhood. Anybody ever heard of G-Force cartoon?
The hamsters?
No. Dumbass movie. Oh well. It's too far back, and then that stupid movie came along. So oh well, too bad. So this is asking you to find the area of this whole thing. And in this section, I can't remember if I actually. It's not on here. It's formula. Yeah, I guess this one. Yeah. Did I really give you once you give you this? I guess I did.
But do we have to slice it in half and then like figure out the?
I mean, the whole idea here is to break this up into two triangles. So if you break this directly in half, then that's 30, 30.
And then just double the area at the end.
Yeah. So there's a Heron's formula that they have in here that you really don't see very often, and I guess I just gave this to you just to see if you could plug stuff into the formula. On page 479. This is not a big deal. So if you have any trouble with this one, don't worry about it. It's really just, can you plug stuff in? And there's an interesting historical note about ways that people try to address these kind of problems. S is 1/2. So for each of these triangles, there's one. So if I just look at that one side, and like you said, you just have to double it. I'm missing one side of it. But that's where the law of cosines comes in. You can find that last side length, because I don't think they gave it to us. No. Okay. Now, a whole other way to do this, let me see, well, I don't know if I want to go there. Well, yes, I do. If I did this, what kind of triangle is this?
Equilateral.
Equilateral, yeah. So if that's 4 and that's 4, then this is 4. So now you got a big triangle that you've got all the sides for, minus this triangle, because you've got to cut that piece out. I mean, there's a whole other way to do the problem without doing getting that side and then going from there. Yeah, this is what I call a cookie cutter problem, because you got some dough, you're going to cook that, you're going to cut that piece out, subtract it out. So I like that way better to look at it. Because now you know this side is 4. So for the big triangle, it's all 4, 4, 4. For the small triangle, it's 3, 3, 4. So you just have to do this thing twice, and this thing is pretty quick. So this, the sad thing about almost every math course you take is there's never really enough time to get into the history of a lot of stuff we're looking at. And a lot of times the history kicks ass. Do you know that there was a car that there was a wheel that would come out in the back and the whole car would move out and then it would just kind of rotate you back, so parallel parking was very simple? Did you know that? Now the reason I'm bringing that up is because there's a lot of things in history that actually were easier, and for one reason or another they kind of got pushed to the side. This isn't exactly an example of that really, but if you know your history, you can kind of bring things back and maybe reuse them and to make your problem easier. If you don't know the history, you can't do that. You don't know where things came from, why they are the way they are. So there's just never enough time to talk about the history. And that might be one reason why I assigned that. As I'm talking about that, I think that's why. Just so you have to look at that Heron's formula.
For 6A, practice test, wouldn't the reference angle be 30 degrees?
No.
Because it's dealing with cotangent.
It's got to be related. No. It has nothing to do with that.
Okay.
120 degrees, how far away from the x-axis is that? It's always in reference to the x-axis. And how far is the x-axis? How many degrees?
Oh.
It's 180 here, right? So it's always in reference to 180 or 0 or 360 or pi, 2 pi. So if you're at 120, you don't do this. That's not the reference angle.
Yeah, that's what I was doing.
You do this. That's the reference angle. Yeah. And that's what I meant by my angle's got to be in the base for this to make sense.
Are you recording that?
Yeah.
Okay. I'll go on. Okay. That's what I kept forgetting.
Yep.
That the reference angle is still that.
Yeah, be real careful. I saw some 90 sneaking in there, minus 90. I should never see that for reference angle. It should always be minus 980 or minus some multiple of 360 or something.
That was me on the quiz.
Yeah.
The 60 then?
Yeah, for 120, it's going to be 60-degree reference angle, yeah.
Doesn't matter if it's secant or cosecant.
Again, a given angle has a reference angle, period. I don't care what trig function, a given angle has a reference angle on its own. And then you can come in and ask a trig value question. Cool. Has nothing to do with the tangent, cotangent, cosecant. It has nothing to do with that. Cool.
And for converting from degrees to radians or whatever, it's always 180 over pi over 180, right?
Yes. Cool. Just make sure your units cancel. So if you're in degrees, you put the 180 degrees on the bottom and the pi on the top.
Chemistry. Oh, like canceling in chemistry.
Like chemistry, yeah, like unit analysis. Exactly. Say again. On the practice. Farmer Bob one. You alright?
Huh?
You alright?
Yeah.
This is crazy. It's really like quiet. Alright. Number 3. Crop circle in the middle of this cornfield. So it's a true circle, radius of 35 feet. And he wants to know the area of the sector with a central angle of 210. So if I go out to 210, I want to know the area of that sector. 210. So the area formula, I'll probably give it to you if they ask you an area question. Anytime you see the angle outside of a trig function, it has to be a true number. Degrees are not true numbers. Radians are true numbers. So I cannot just put 210 here. I have to convert that 210 to radians first. Does that make sense? So sine and cosine and tangent, they can handle degrees. They convert that into the same number. They don't care if it's degrees or radians. If it's sitting out by its own, it better be a true number, and radians are true numbers, not degrees. Degrees are things we made up. So the first step here is to convert 210 to radians. And like we just said, 180's got to go down there, pi radians up there. So you get 7 pi over 6. And now you just got to throw that in the formula. I know theta now, I know r is 35 feet. So they get the area. Cool. I think when I was making the answer key, I started doing arc length. Oh shit, I want area. That's not too bad, right? So I explained all that scribble. And go ahead, I mean, it's not bad if you stop with a pi answer with some number in the front, but you know, if it's a real life problem like that, you're not going to tell somebody, you know, oh, I bought some land. I bought 17 pi acres of land. What the hell's that? You know, give me a decimal so I know what the hell you're talking about. So go further to the decimal. So is that cool for part A?
And I know you said that we have to remember these formulas. Do we have to remember a formula like that?
No, like I just said, if I ask an area formula, I'll put it on.
Oh.
Yeah. And I really would have liked to have made you guys memorize this because it's not. I know the area of a triangle is 1/2 the base times the height. And what's the arc length of something? What's the arc length? Who remembers that? The arc length is r theta. So the area of the triangle, 1/2 the base times the height. So 1/2 r squared theta. There it is.
I still want to remember another one.
You lost me at I don't have to memorize.
That's when you were doing the tangent graph and you said there's not going to be any tangent graph. I said, oh, time to knock out.
I know. Now here, the nice thing with the part B is they give it to you in radians already. The angle. And the radius is 35, so you just got to multiply that out.
Can't you do number 5 on the
Oh yeah. Let me show you any question like that, the number of revolutions that something circular goes through. One revolution is equal to what in this case? I mean, so if I have a wheel, what is it, 28-inch diameter? One revolution. How far would this wheel actually, how far would I move if I let it rotate one?
360 degrees?
Interesting. I'm talking about how much forward motion would I have? You're not going to tell me that if I go to the door, that's 87 degrees. That doesn't make any sense. So the wheel is rotating. What is my car doing? Going forward. Straight. Find the perimeter, which is also known as circumference. Cool. So if you know the circumference, that is what one revolution translates into as linear motion. Right? So for bigger wheels, one revolution would of course be a lot further. Tiny wheels, they gotta go just to get somewhere. So all I gotta do here is 28 pi and then whatever the hell that is. Right, pi d for circumference. And that formula I'm gonna hold you to. And now you just say, if I went 10 revolutions, it would be 10 times that. If I went 20 revolutions, it would be 20 times that. This is backwards. This is, I know how far I went. How many revolutions must I have accomplished then? And you can actually look at it just like a conversion problem. 28 pi is one revolution. 28 pi inches, right? So if I know I went, what was it? 30 minutes, 60 mile an hour is 30 miles, right? Half an hour. Is everybody cool with that piece? Going 60 mile an hour for half an hour, that's 30 miles.
Yeah.
So gone 30 miles, convert that to inches. So I love this problem. Sorry.
How many feet are in
300
5,280.
There it is.
billion.
30 miles. So there's 1 mile is 5280 feet, and 1 foot is 12 inches. And the cool thing is, now watch, you can actually continue this. How many inches is 1 revolution? We just figured it out. 1 revolution is 28.5 inches. 5280, yeah. So it's really just one more step on your conversion. How do I, because I know 1 revolution is 28.5 inches, just like I know that 12 inches is 1 foot. I can make it one more conversion step. I separated it on the answer key, but you actually just do it in one big old last step. And there were problems like this in the homework. Yeah.
What exactly happened in number 4? What is the? I just don't understand what I'm looking at here. But what's greater than angle, which is?
So given secant theta
Yeah.
is 25 over 24,
Uh-huh.
and theta is in between 3 pi over 2 and 2 pi. So what quadrant is that?
Oh,
Yeah.
I see. That second part is just to tell you what.
It's
quadrant.
information. It's not part of the question.
Gotcha. Okay.
It's another way to say quadrant for you.
Did you do number 10 on the practice test?
I keep like missing
They keep
you,
on
and then they
doing
keep
the ones I
asking
want.
us again.
Yeah.
So 10 on the practice.
Yes.
Okay. Let me see if I can do this so I don't have to wake him up. So this is on a calculator, right? So on your calculator, you would put. Yeah, actually I do.
Mine doesn't accept or doesn't convert cos.
So you would put, here's how to solve any equation. Any equation. So in this case, this equation. You put this into y1, this into y2, and of course the answer is going to be where those two graphs do what? Where they meet.
Oh, so I just did do my window. So I don't see one line.
Oh yeah. Okay. So you got to make your window something that'll accept these. It doesn't be anything too freaky. I mean, cosine goes between 1 and -1. Inverse tangent is between -pi over 2 and pi over 2. Its amplitude has changed a little bit, but if you go, well, let's see what we get. So let's see what we all get. And a little note, you want to be in radian mode when you graph. Trust me. Everybody, don't forget inverse tangent, right? So don't just hit tangent. Everybody, let's make sure we're all on the same page. Everybody, when you get the graph, hit zoom 6. Let's all be in the same place. And that place is kind of an ugly place. So if you hit zoom 6, you should be in this place here. Something like that. You guys have something like that? Good. So obviously now we go in and we adjust things a little bit. So zoom 6 is not a bad idea when you put something new in. So obviously I'm seeing a lot more stuff than I need to. So I can bring the Ymin and Ymax in a bit. And I'm seeing way too many I can see that the one kind of goes above the other one eventually, so I don't need to see so far out.
Why does it have little dots?
So again,
Why does it have little dots? Has little dots.
oh, yours has measles? Does it have little dots all over the place?
A little bit.
I don't know.
Like,
Yours is just freaking out. Sorry. So hit window.
The zoom box.
Uh, hit window. We can do zoom box, but hit window, and I want to go. Cosine only goes between -1 and 1. So let's go -1.5 for the y min. Be careful that you put the real negative sign in, right? And 1.5 for y max. You guys with me? And in the problem, it says I want all the answers from 0 to 2 pi. So for x, oh crap, what did I just do? Make sure that you don't do what I just did. Y min is -1.5. Y max is 1.5. Now x min go back up. Make the minimum like -1, and the max 2 pi. Yeah, for x.
So minimum 1.5, -1.5.
So y min -1.5, y max 1.5, x min -1, x max 2 pi. So now we have a picture like this. Right? And I can see my answers are here, here, and here. So now I can use that intersect. Go to second calc, intersect. Intersect is number 5 on that list. And then just move your cursor until it's on top one of the intersections. Enter, enter, enter. So the cool thing to realize about this is I don't care what is involved in your equation. If you had log of tangent of 3x minus 7 equals the square root of e to the log sine inverse of secant x. Holy shit. So you just put one side y1, y2 equals the other side, see where the graphs meet. There's no damn way you're going to solve that equation by hand. No way in hell you're going to do it by hand. So that's where graphical methods come in. So there's a whole branch of mathematics called numerical methods that says, here's a bunch of problems you can never do by hand. How can we use technology to get better and better approximations to the answers? And then you go to 10. Right? It's a whole branch of math saying, we admit you can't solve every equation.
Are the answers points, such the 3 points, or do we just give x?
Well, the answer is the variable involved, which is x. So my answer, I'm going to have 3 x values. The y values really don't mean that much to the equation. Right? They happen to be what the value is at the point for the individual graphs, but all I need are what inputs make that equation work, just the x values.
Think I'm good?
It's all up to you guys, because I have no more to say unless you have a question. And again, I think I forgot to do this earlier, but I don't think I have anything happening Monday, so I think I'll have office hours right before class again on Monday. Normally I don't, because normally there's a Senate meeting or there's a chairs and coordinators meeting. I think this Monday there's neither, so
What's your earliest office hours on Monday?
I'll send an email out as soon as I figure out what they'll be. Yeah.
Are you here on the next one?
Yeah. Tomorrow I'm here at a time you probably don't want to come. 7:30 to 8 because I have an 8 o'clock class, and then 10 to 10:30. And Friday I'm not on campus really unless there's meetings. Yeah.
Is 12B then Or did you just leave it for us to finish the sine side?
Do you
Uh-oh.
like do Google Prop?
Which one?
Oh, this one.
Like Lindsay Trim,
Oh,
the same
yeah.
thing?
No problem.
Minusing the two
Oh no,
fractions and then.
that whole thing, cosine, cosine, sine, sine, is cosine A minus B.
Oh, okay.
So that whole thing becomes that what I have. That's using the addition subtraction formula from that 7-2. Yeah.
6.645. That's the last one.
Thanks.
No problem. Man, oh. So let's see. So it goes. This is 70. And travels 30 miles, so that's 30 miles. Which is Egg Island, of course. The next day he sails 10 degrees east of north. For 50 miles.
Wait.
What's up? Is it the right prompt?
No, I got it. I just looked at it again and I just clicked.
Cool. I like it. That's
Damn it. Thanks.
Not sure what I did, but yeah. Sure.
You're just that good.
Yeah. So you guys okay otherwise?
Yeah.
Yeah, I think we're good.
Sure.
What was it? Cosine?